Hi, all, and good morning. Thank you so much for joining today. Very excited to have you all here. Whether this is your first session, welcome, or you've come to our previous ones, welcome back. We're really excited to continue chatting about our most recent spring release and all of the exciting features and functionality that we released alongside this major release for us. I'm really excited today to have a chance to have all of you guys hear all about our enterprise catalog. And with this, I am excited to introduce Mark Hirth, who is our principal product manager here at Dremio, to walk through all things enterprise catalog and give you some background and show you what the latest and greatest is with our newest release, and also go through a demo. I do want to encourage everyone, if you have questions, please feel free to throw them in the chat. We will be, Mark will be answering these as he goes through his presentation, but we will also have time at the end for Q&A. So with that, I will hand it off to Mark. Mark, the floor is all yours.
May, thanks very much, and thanks to all of you who joined today. We want to talk about Dremio's enterprise catalog and some of its very unique advantages that it offers you in our version 26 that we just shipped. In order to understand the enterprise catalog, one has to start out by thinking about the lakehouse, because the catalog is the principal driver of the lakehouse. The lakehouse is typically broken up into several architectural layers, as you can see in this picture, and the best way to read this picture is to start at the bottom. It's typical, back in the days when we had a data lake, that you would have object storage and you'd have a bunch of files on object storage. And that's still true of the lakehouse, but the primary differentiators of a lakehouse really involve the intelligence that's added on top of a simple file, because at the bottom of this architecture, you can have S3, you can have a Parquet file. But on top of that, the Iceberg format unifies Parquet files into an intelligent file format that can tell you so much about the content of the file and can speed up query processing based on metadata. Then you need a catalog in order to store metadata to make it available to the query engine. And on top of that, you add access control and a variety of other things until you finally get to the top where you're ready to run queries from your favorite BI tool. But you can see here so many different things have to play together in order to get the lakehouse to materialize into something that's actually enterprise ready. And Dremio has perfected this concept into what we call the intelligent lakehouse platform. So again, reading from the bottom, this picture looks a lot like the last because we have object and file storage at the bottom of any lakehouse architecture. And that's really important because your favorite S3 bucket or ADLS bucket or whatever you choose to use for storage is still going to play an important role in the lakehouse. This isn't a subsumption of all the technology to be within a big firewall. A lakehouse is the incorporation of open source technology like your cloud storage platform and your enterprise catalog, because notice the bucket above that is the enterprise catalog, which is so important in an Iceberg situation because it's the place where the root metadata pointer is available to a table, and the query engine follows it to get the metadata for a table and eventually the data for a table. Now, an enterprise catalog can be of many different forms, and what we're here to talk about today is the great features of the Dremio Enterprise Catalog, which is powered by open source called Apache Polaris. We'll talk a little bit about where Apache Polaris came from and why it's great, but for now, the number one thing to see is that it's a full-fledged Apache project, which means that it's completely open source and a ready companion for Apache Iceberg. The two of them go together beautifully. Now, on top of an enterprise catalog, Dremio has added a concept called acceleration and a acceleration technique called reflections. A reflection is a lot like a materialized view, except for the fact that in Dremio's case, it's a managed materialized view, which means that Dremio takes all the responsibility for creating them, managing them, updating them, and making them fresh when you add or change the data in a table. And so you don't have to do anything to make these materialized views available, but you do get to realize the power of how they can accelerate queries, because you no longer have to do a join when your query is being executed. You no longer have to do a very compute-intensive aggregation when your query is executed. That could all be done in advance and made ready for your query when the dashboard runs. And so what you can typically find is 80, 100% performance improvement through a reflection. On top of that, you have Dremio's AI-ready semantic layer. The semantic layer provides a visual representation of all of your tables and their various directories, folders within your data lake. So now it's not just one big open sea of stuff. It's an actual organized collection of tables according to an organization that makes sense to you. It can be the departments in your organization or specific projects, and you have a series of permissions which control what's available and visible to all the users in your organization. So now this is starting to look much more like an enterprise data warehouse, which is exactly what the lakehouse has become. On top of that, you have your favorite business intelligence layer, and all of a sudden we've got something that's very enterprise ready. Now, in the case of the catalog, let's talk a little bit about why the catalog is such an emphasis for Dremio in this release. Apache Polaris is the open source Apache project for a catalog that's meant to accompany Apache Iceberg. And its origin is particularly interesting because it was started by the two basic leaders in Iceberg space, that being Dremio and Snowflake. Between the two of us, we founded the Apache Polaris project and created the Apache Polaris catalog, which is now an incubating Apache Polaris project. You can obtain Apache Polaris catalogs through the open source community or through one of the vendors that make Apache Polaris available in part of their solutions. Dremio being one, Snowflake being another, and eventually I'm sure there will be many others. Apache Polaris has many features, which you can see in the middle of this chart. It supports Iceberg tables and views, no matter where they're created. It has a provision for namespaces and role management. And over on the right-hand side of this picture, you can see that it provides credential vending, Iceberg REST protocol support, and most importantly, it's open source. It's completely open source, according to the rigorous standards of the Apache community. Dremio, being one of the vendors who support Iceberg and Apache Polaris, have packaged the Apache Polaris catalog into an offering that we call the Enterprise Catalog. And we've added some value-added features that make it enterprise ready that we'll talk about briefly in this presentation. We've added Iceberg Clustering, which is an amazing feature to dramatically improve the performance of your queries along the lines of what partitioning would have done in the past, except that Iceberg clustering is significantly easier to achieve than partitioning in almost every case, and will give you equal or comparable or better query performance, depending on the content of your table, for far less effort and far less maintenance cost in the future. Dremio has added automatic table maintenance, so we can automatically optimize your table or vacuum it according to the specifications of your table and make it query ready at all times. We've added integrated role-based access control, or RBAC, and along with that, the demo I want to show you today is for integrated fine-grained access control, or what is sometimes called FGAC. And between these two, role-based access control and fine-grained access control, you have the mechanism to control the privileges for who can use a table, who can query a table, who can modify a table, down to the individual rows and columns in that table. So you have amazing control, equal to what you would typically find in an enterprise data warehouse of the past. Now, what this means is that the Dremio Enterprise Catalog takes the foundation of Apache Polaris and makes it really available for your enterprise in a package that's ready to support your most complicated use cases. First of all, the Enterprise Catalog is enterprise ready. And what I mean by that is that it's fully integrated into a Dremio release, and I'll show you in a few minutes exactly how that looks on the screen of the Dremio product. It's fully integrated into version 26, and it's backed by Dremio Enterprise support. This is so important because it means that you have our entire team at your disposal whenever an issue arises or you have a question about how to use the product. Second of all, the Dremio Enterprise Catalog provides governance. We talked a little bit about that in the previous slide. You have role-based access control. You have fine-grained access control. Dremio has integrated Apache Polaris with external IDP. Identities that you have from your IDP can be available to authenticate your access through the Dremio catalog or using the REST API. Finally, I'll show you the data lineage that Dremio has added to the product. And so you have a complete visibility of the view or table that you've created, and then all the tables or views that lead in the chain to the eventual data source, which might be an S3 bucket or an ADLS bucket, that kind of thing. And then finally, Dremio has spent an incredible amount of effort making this a performant solution. And what I mean by that is that we've added automatic table optimization so that your table is always ready for a production level query. We've added Dremio clustering to make the performance of complicated queries that would have required partitioning in the past to be just as easy to attain in a fraction of the time that it might have taken a partitioning solution. We've added metadata caching so that the metadata is always available in the catalog and it can cut down on the time for retrieval. So many different functions here that have been achieved in order to make the catalog ready for your most complicated queries. Now, let's take a look at some of the details behind some of the features that I just mentioned, because there's a lot of substance here, and I'm only going to have a few minutes to touch on some of these topics, and then I want to show you a demo in order to show you what I mean, but this will set the stage. I mentioned that Dremio has integrated role-based access control, and this gives you a high-level sketch of the kind of privileges that you have available to grant or revoke to any user or role in the Dremio system. For example, if I want to give the user the ability to read a table, I would grant select privilege on that table. Notice that in the second column there, reading and writing data, I have both select and write. So I could grant select privilege to a user or role. And when I grant select privilege to a role, it gives that privilege to all the users in the role, or I can grant it to an individual user. Dremio's system is flexible to allow grants to either type, users or roles. And then you can see some of the other privileges that we provide. If you want to give a user the ability to create tables or manage grants, which means the ability to perform these grants to other users. But notice the level of control that you have. Very granular, and it gives you complete control over exactly how much you want your users to be able to do within each folder, within each data set, or within the catalog as a whole. Now, the demo I want to show you today is fine-grained access control, which is it's a hard to understand term because it's not immediately clear what's being referred to here, but this is control down to the row or column level. And so notice I've got two different rows here, one for row filtering and one for column masking. The reason why I've focused on this is because Dremio is currently creating a version of this functionality to contribute to the Apache Polaris open source community. And we're planning to make it available later this year. So this is a great thing to learn a little bit more about because it's only available within Dremio today, but it will soon be available through open source as a result of a Dremio contribution. What we have here is the ability to create policies. So notice in the first column, I have some policy definitions for row filtering or column masking. And once I create the policy, I can bind it to a table. And each one of these policies is a simple SQL expression. So in the row filtering case, I'm going to create or replace a function that filters on a column and gives me all those values where the column value is greater than some number. I've chosen j equal 1 here. We could choose j equal 2. The important thing is that your policies are simple SQL statements. And so all of a sudden, you can do anything that a SQL function can do, which is an infinite, gives you infinite power to express the kind of logic that you desire. And as long as these functions either return a Boolean or a value, we can use them to either filter on rows that we want to appear in a table as a result of a select, or mask values. For example, we can replace values with X's or stars. We could show the entire Social Security number or any part of it, that kind of thing. And we can control all this very, very quickly and easily through any number of policies that we want to attach to a table. I'll show you this in a few minutes. We'll talk a bit in this presentation about automatic table maintenance, because one of the things that can dramatically improve query performance is a well-optimized or vacuum table. And we have here the two primary ways that table maintenance occurs, either through optimize or through vacuum. Think of optimize as a way to compact small files and split large files where required in order to create optimal table file size. Lots of small files, especially, can degrade performance because every small file that has to be opened, we have to read metadata, we have to go through file I/O operations. That can be detrimental to query performance. And so one of the most important functions of Optimize is to rewrite and consolidate, compact many small files into larger ones. On the other side, vacuum is basically a garbage collection function. It can expire old snapshots, remove orphan files, and you can do either one of these operations manually or leave it to Dremio. We perform these operations automatically according to the needs of the file. The last thing I want to mention is a little bit about Iceberg metadata, because Iceberg itself provides 4 different types of metadata that you can read directly from the SQL command line. Table snapshot is a file, and I've even provided a query example here. Look at the example in the middle of the slide. Select from table, table snapshot. Notice what I'm querying, though. I'm querying a Snowflake Open Catalog. These Iceberg metadata operations are available for any Iceberg table, no matter where it's located. And I'll show you in my demo in a minute. I've actually integrated a Snowflake Polaris-based catalog. We'll take a look at a table there, and we could run one of these metadata queries on the table. And what we'll see is a list of the snapshots from that table. All of a sudden, the benefits of Iceberg are becoming apparent because we have all this interoperability associated with tables in the catalog and the catalog itself. Once we do snapshots, we can look at files, we can look at individual tables, et cetera, et cetera. We can do time travel queries. You're probably familiar with that through other webinars or discussions, and the possibilities through time travel queries is immense. Okay, finally, we're going to talk about Iceberg clustering in a minute, but at this point, I'm going to change what I'm sharing on the screen, and I'm going to break out of my slides, and I'm going to show you my screen in a slightly different way, because I have 2 Dremio clusters here. Right, I have 2 screens, I meant to say, on one Dremio cluster. This screen is for a user named Gnarly, who is an administrator of my cluster, and this other screen over here is for a user named Mark. Notice the user information on the bottom left-hand corner of the Dremio screen, who is a normal user. And I've shown these 2 screens in order to give you 2 different perspectives on the table, which we're going to take a look at in a minute. This is the home screen on Dremio version 26, and notice on the left navigation panel, we've got a couple of pretty interesting things right off the bat, because the environment comes with an integrated Dremio Enterprise Catalog. This is the Polaris catalog that we've been speaking of. And in the Polaris catalog, I have already added some folders. I can add folders of any depth. I can go into these various folders, and I have tables here that I have created. In fact, I'm going to show you exactly how I created one of these tables, and we're going to do some FGAC operations on the table in order to show you how we can specifically limit the rows and columns that are accessed for any given query. But before we get to that, I just want to show you, as I mentioned a minute ago, that Dremio added support in this release, not only for its version of an Apache Polaris catalog, but for any version of an Apache Polaris catalog, because here, through this dialog box where we're adding sources, we can add other catalogs. AWS Glue, a Dremio catalog based on Apache Polaris that's external to the project, an Iceberg REST catalog that you may have downloaded from Polaris OSS page or some other source, or catalogs that you obtained through Snowflake or Databricks. I've actually done that prior to this session, and so look what I have here. Here is a Snowflake catalog that I obtained through my Snowflake environment. I can show you here if I open this, and I'll show you the settings. Here is the endpoint for my Snowflake catalog. In my Snowflake environment, I used my PAT token as Snowflake recommends in order to get access to this environment. And if I go here through the various layers that Snowflake has set up for me, there's my table, and I can query the table just by hitting a run on Dremio, and it's one table. It's only got a few rows, but it proves the point. We can query tables that are coming from a Snowflake catalog, and similarly, if I go back here, I've also integrated a Unity catalog. Let's go here to look at the settings for this. Here's the endpoint for my Unity catalog that's coming from my Databricks environment. I can do the exact same thing here by virtue of the Apache Polaris Iceberg REST catalog that they have standardized and all these vendors are now supporting. And this level of interoperability is so great because you can imagine the ability to unify all the operations in your operation now around a single perspective, a single screen where you can get access to all kinds of catalogs from all kinds of sources. Now let's go back with this being said, because I want to focus on the Dremio catalog. And as I mentioned, I want to show you some FGAC operations. So I'm going to go here to a table I've created, and it's called test table. We're going to do a little run on this table. It's got 6 rows in it. Every row is an integer and a name. And I've created a sequence of operations, which I want to show you here, because right before the demo, what I did is this series of steps where I created the table and inserted some values. That has given me the table that we looked at just a second ago. So we're going to run that again just to show you this. And just for fun, we're going to go over here to my other window. Remember, I said this was a different user. This is a normal user, Mark, who does not have administrative access, but this user has access to the exact same table and can run the exact same query and see the exact same content. Now, the idea of role-based access control is that you can set up the users who get access to a table. I've actually taken care of that already. But we're going to create a policy that is going to give us fine-grained access control. Here, we're going to create a function that filters values, and I'm going to select values where the incoming value is greater than 2. Let's create this function. And because this is a function in a normal SQL process, we can actually run this function. If we run this function, we'll get the value that was returned here. Notice I defined this function to return a Boolean, and it does return a Boolean when the incoming value is greater than the prescribed function here. But I could have defined this to return a Boolean with any given logic. And so we're going to apply this to my table that we just created, and we're going to filter the first column according to values that are greater than 2. And what's going to appear in subsequent selects are only the rows that fulfill this policy. Let's go ahead and do that now. We're going to install this policy on the table that I showed you a minute ago, the test table. And then we're going to run the exact same query. Notice it's the select star on the entire table. But look what I get. I only get those rows that fulfill the policy. It has omitted rows 1 and 2, where the values were 1 and 2 with different names on it, because they don't fulfill the policy. So I've been able to create a row policy for filtering rows that is, from this point, transparent to users of the table. I can actually attach additional policies to the same table. So look at this. I'm going to create another row filter that's going to filter for strings that don't start with the letter D. Notice row 3 here, user Dremio starts with the letter D. And I've decided for whatever reason, I don't want that user to appear. So I'm going to create a policy here for anything that starts with the letter D, and then I'm going to try this in a couple of different ways. Notice how I'm highlighting individual SQL operations in the SQL runner here to show you the flexibility that you have through the SQL runner. I could either run this whole thing as a script, or by highlighting individual commands, I can actually just run these steps one at a time. When I choose to highlight two different SQL operations, I have two different SQL results. The first one here, when I ran this thing with Dremio, it returned false because it does start with a D. When I returned it with a different string that does not start with D, it returns a true. And that's exactly what I want, because I'm going to filter according to strings that don't start with the letter D. Those are the ones that I want to remain. We're going to attach that on my table. And then we're going to run the table again. And lo and behold, user D is gone. And the previous policy of filtering out those users, those rows that start with a 1 or a 2, are also removed. So what I'm trying to illustrate here is that we could apply any number of policies to this table, and every policy can be applied to any number of tables. So we have a very compact way of expressing the policy logic that we may want to apply to a multiple number of tables to achieve the row filtering we desire. Now notice over here for user Mark, Mark has absolutely no idea that there's been any policies installed on a table. He's a normal user of this table, and he gets the result we intended. But what if I want to select different versions of a table for different users? Or let's suppose I want to mask. Let's go to that next, because what we're going to do is drop those policies that we just created on the table. We'll get rid of those row filtering policies. We can actually show you that those policies are dropped. And I'm going to do this through two different ways. Notice here that I'm doing a select on the table, which is just the table name, and I'm also doing a select on what we call the fully qualified table name. And the fully qualified table name starts with the catalog name, and it goes through all the various folders until we get to the base name. Well, how is it that we can do these operations to attain the same result? How does Dremio know that test table refers to catalog name, folder, table name? And the way it does that is through something here at the top. Notice I've said something here in this window called the context. The context is an abbreviated way to point Dremio where the table is located, so I don't have to type the fully qualified name all the time. I don't have to do Dremio or catalog. All I have to do is show the base table name, and it knows through the context what I'm talking about. But in the event that I do a drag and drop or something like that, and the full table name appears, that also works. So we can show that those policies are dropped either by looking at either one of these query results. Notice what we've got here. The full table is back again. And what we're going to do now is create a column masking policy. We are going to allow Mark, which is the user in the other window, to see all the data, but everybody else is going to get a masked version of the data, which is a series of X's that's as long as the actual value was before the mask occurred. So if the original value was 3 characters, we're going to get 3 X's. If the original value was many characters, we're going to get that number of X's. Now, you may say, well, I don't want that kind of a mask. I want to filter out the last 4 digits of a social security number, or I want to filter out the possibilities are limitless, because this is normal SQL, and you can express any kind of a policy you want here. I just chose this one for fun, and so there it is. We can actually run it because it's a normal SQL expression. If I give it a character string of 6 characters, I get 6 X's. Okay, that's cool. So let's install this policy on my table. Notice how quick and easy this is. I'm going through this fairly quickly because I've got it already expressed here, but all I did was alter a view on my table. I'm going to modify a column and attach my column masking policy. So then when I run it, what I'm going to get here as a user who's not Mark, I'm actually the administrative user, but I wrote my policy to give data access to Mark alone. Dremio actually allows you to filter identities either according to the username or the role name. So I could have equally chosen all identities that are in a certain role, like the marketing department or the engineering organization. In this case, I just chose one user name in order to make a simple demo. But look what I've got. All of my values have been masked in exactly the way I desired. And if I go over here to user mark, look at this. I'm going to run the query as user mark, and I still get exactly what I intended. Mark gets access to all the data. So you can imagine how great this would be if you want to filter certain values for certain users, certain roles. You only want to filter some of the values. You only want to partially mask some values. All of that is very, very easily achieved. Then what we can do is drop the policy. And we're back to the original table. Boy, time's really getting away from us here, and there's a couple of other things I want to show you. And so I look forward to any questions you may have at the end. But let's bat clean up on one final thing I want to show you, and that has to do with Iceberg clustering. If you've been involved in attaining performance from a complicated, very large table, you know the incredible value of partitioning. A partition is a hard directory-oriented organization of all the data in your table. So what the query engine does when you partition a table is it creates subdirectories in your cloud storage. Let's say you partition by date. And so we're going to have directory 1 that's this date, directory 2 that's a different date, directory 3 is a different date, and we're going to organize the data into those various directories. And the reason why this is going to be phenomenally important is because if we do a query by date, we're going to go directly to the directory where that relevant date is, and we're going to cut out the other 90% of the data, and we're going to attain much, much faster query performance. And so that sounds great. What could be the issue with that? Well, it's also entirely well known. Partitioning is hard to do. We don't always know what value to partition on. It requires upfront planning to achieve. Table maintenance has to be regularly performed because our partitions can become imbalanced. If we have a partition that has 2 records and a partition that has 2,000 records or 2 million records, all of a sudden the partitioning is not going to do as much good for us because our partitions aren't balanced. And so there's all kinds of technical considerations about the effectiveness of partitioning. And so along these lines, Dremio, in this release, created Iceberg clustering. Phenomenally easier to achieve. And the basic idea here is that you identify a cluster key, and Dremio packs each storage block with enough files to fill that storage block, and it uses Iceberg metadata to direct the query engine to those values that are within that storage block. But no longer do we have a rigid partition system where every directory has to be created and every directory has to contain only the records that are matching that search key, because that results in a variety of the issues we had before. All of a sudden with clustering, we don't have to have all the regular maintenance we had before, and yet we can attain the same performance that we had with partitioning. Now let me show you a simple example of how this works. Here's an unpartitioned table. We've only got 16 records here, but we've got dates that range across a variety of values, and then we've got some other records, some other columns in the table. So if I were to do a metadata query of table files, by the way, this query was exactly on our previous slide. This is one of the metadata queries that we can pose on any catalog that contains Iceberg metadata. So I could have posed this query to my table on a Snowflake catalog or a Unity catalog. So here's my metadata query. I've got one partition. This is not partitioned. It's not organized in anything. Or it's 16 records in here, and they're all over the place. So if I have any query, I'm going to have to do a linear search across all 16 of these, or 16,000 or 16 million, in order to find the stuff I'm looking for, and that is slow. So let's partition it. And what we're going to do in partition is create directories. We're going to put the files we're going to put the records into the appropriate directory. And okay, well that looks great, and that's going to give us much better query performance if I have a query that keys on date, because that's what we partitioned on. If we haven't keyed on date, we've got a much different situation, and we've got very uneven partitions here that may need to be rebalanced on a regular basis, and it can create a variety of other issues. And so let's cluster the table. What we now achieve is one storage block with all of the records in it. Here, this slide shows that the records are sorted. They need not be. The important thing is that we use the Iceberg metadata to point to the storage block that has records in it from this to this, that the query engine can see and say, well, either this block has my data or it doesn't, go on to the next block. And so all my storage blocks are full. I no longer have these hard partitioning boundaries, which means that it's much, much easier to maintain, yet directs me to the exact storage block where my data is located. Now we're quickly running out of time, so I want to make a plug for a couple of other areas of additional information that you may choose to take advantage of. This book on Apache Polaris, as the definitive guide, is available from O'Reilly from Dremio authors, and you can download this book for free by using this code that's over on the right-hand side of this screen. You can also take advantage of courses that we've made available on Dremio University for additional information about Polaris or Iceberg, or gosh, there's a variety of stuff there that's all really great on a variety of topics. And there are nice badges that you can earn. I've done several of them, and they're very comprehensive. They give you really nice course outline here, and so you may choose by using this code over on the right to take advantage of some of those. They're all free and available to you. All right, well, we're almost out of time. I'd love to take your questions here in the next few minutes. What are our takeaways today? The Dremio Enterprise Edition, version 26, that we just shipped, includes the Apache Polaris Enterprise Catalog. It includes the Dremio Enterprise Catalog based on Apache Polaris. This gives you an enterprise-ready catalog based on open standards that can provide a wealth of capability for your most complicated use cases. It includes governance, including the FGAC that we saw demonstrated today, and it will optimize the performance of queries through a variety of technologies such as automatic table optimization, clustering, metadata caching, etc., in order to achieve the very best performance for your most complicated queries. Maeve, we've got just a couple of minutes left. I'd love to take a question or two.
Oh, perfect. Thanks so much, Mark. That was great. I do want to say a big thank you for going through that, super detailed demo. I think that's awesome to be able to see. Do want to call out a big thank you also to Keith, who I do see from our team jumping in on the chat there to help answer some questions. We do have time right now for any of you that may have additional questions on anything Mark covered. Happy to take this time now. And as you're typing up those questions, I will also add on to the great resources that Mark outlined. We do have additional content on our launch blog around Dremio Enterprise Catalog, which I will share in the chat, which also then leads to the documentation for the Enterprise Catalog there. So you can go back and reference, if you didn't take all the notes during this session on all the great things Mark was highlighting, you can go there as well. But like I said, if you do have any questions at this time, please feel free to pop them in the chat. This is our Q&A time. Give everyone a moment as those come in. And like I said, I will be linking the launch blog in the chat right now. Great. I do think I see one from Guillaume with the question of, do RBAC settings persist also in external Polaris catalog?
Yes, they do. Catalog RBAC and FGAC settings are made within the catalog itself, and persist in the catalog.
Perfect. Let me double check. I believe that's all we've had come in. And like I said, if there are any other questions, I did post the launch blog along with that has the documentation embedded in there. And for any of you that want to rewatch this session, the recording will be available to you all in a few days. But I appreciate the time. Oh, beautiful! And one more question. Love this. Another one from Guillaume. Does that reflect the IDP integration?
I'm sorry we didn't get a lot of time to talk about IDP integration, but the users that we used in the FGAC policies could have either been locally authenticated users. That's what Dremio's term for users that are authenticated through a password within Dremio, or they could have been externally authenticated users through an IDP. Dremio also supports OAuth tokens for access through the Dremio, the Iceberg REST API. So you can obtain a token from your IDP, exchange that for an OAuth access token from Dremio in order to get access to all of the Iceberg REST APIs. So in a couple of different ways, we've integrated your favorite IDP into authenticated Iceberg users.
Perfect. Thanks so much, Mark. With that, we are going to go ahead and call it for today. This has been a great session. Thank you for all of those that joined. I do encourage you, we do have another session this time next week on our semantic search with Isha from our product management team as well. But if you have any more questions, I know Keith just also posted links as well in the chat, but thank you all so much and look forward to seeing you on the next one. Thank you all.
Bye-bye for now.